Descriptive statistics for spatial data is much the same as non-spatial data. It's just that in this case, we are summarizing visual data that has a spatial component. This chart here shows the differences or similarities between different types of spatial measures we can use and their non-spatial counterparts. So for example, with non-spatial data, we might use mean to show the middle of data, whereas with spatial data, we might use the mean center, which just accounts for the X and Y component. In terms of absolute dispersion, we would typically use standard deviation in a non-spatial data set, but with a spatial data set, we can use standard distance. And there are other measures that are similar to non-spatial data, and I will go through it in the slides. So first we have the central tendency measures, and the first of which is the mean center. So this diagram shows it pretty well that the mean center is a location in two-dimensional or three-dimensional space that is the average of the X and Y coordinates. So this is also known as the center of gravity, and it's essentially just the geographic center of your data set. The mean center is just as sensitive to outliers as non-spatial data, but in this case, an outlier would be a point in space that is far from the other points in space. The mean center calculation is very similar to how to calculate an average with non-spatial data. It's just that you're averaging the points based on the X coordinates and the Y coordinates. So you're adding up all of the Y coordinates and then dividing by the number of points, and then you're adding up all of the X coordinates and dividing by the number of points. And then that resulting X and Y coordinate is your mean center. A weighted mean center is also very similar to the weighted mean in non-spatial data, in that you're taking the mean center of the X and Y coordinates of your spatial data set and you're adding in another variable to weight the location of your data set. So as you can see with the calculation, you're just taking the coordinate and multiplying it by some sort of other numeric variable in your data set. And the location of the mean center is not only based on the location of other points in your data set, but it's also then being pulled toward the higher numeric values of whatever weighted variable you're using. And this will be much more clear when I show you what a weighted mean center is in the R tutorial later on. The median center has a number of different definitions. However, the most common median center is the location in space that minimizes the distance to all other points in space. And this is often called location allocation in transportation geography and other things like real estate geography or business geography, etc. We're trying to locate a building in a place that minimizes the distance to your variable of interest. So for example, if you're trying to locate a fire station in a city, you want to minimize the distance to houses or businesses in that area. And similarly, locating a business, you want to pick a location that minimizes the distance to your marketable customers. This is often a much more difficult task to compute, and thus it is really only available to computer software that can calculate all of the data. And you'll see in the R tutorial, it has its limitations based on the computing power. So in terms of dispersion measures, we first have the standard distance. And the standard distance is a measure of your spread of the point data set. So you can see in the picture, there is a number of points, and you're essentially measuring the average distance from the mean center. The calculation is there as well, and you can see it's fairly easy to calculate, and I'll show you how to calculate this during the R tutorial. The standard distance is a good way to compare different data sets or different point data sets. Now, the weighted standard distance is very much the same as a weighted mean, where you're taking a variable of interest and you're using it to weight the standard distance measure. And you can see how similar the weighted standard distance calculation is to the original standard distance calculation. So based on your variable of interest, your standard distance will get larger or smaller based on that variable's characteristics. And again, this will probably make more sense in the tutorial. Another measure of dispersion is called relative distance, which is very similar to the coefficient of variation that we use for non-spatial data. This is a means to compare the spread of data or spread of point data in a space based on how much room your point data set takes up within your study area. Relative distance is a very easy calculation where you're just taking the standard distance and you're dividing it by an area. The area could be a study area. It could be the boundary of a city, for instance, or if you don't have some sort of boundary that's already been created, some sort of administrative boundary like a city, a province, etc., you could create your own area, such as a circle or a square around your data. It's just a means of comparing the spread of your point data within a study area. The last measure of dispersion we'll talk about is called the standard deviational ellipse. And it's very similar to standard distance, but you'll also see the orientation or direction of points and the spread in both the X and Y axis. So you can see there in the picture, you have your point data set in red, and you have this green circle with the blue line showing you not only the pattern of or shape of your data set, but also how far the data set spreads out both in the X and Y axis. The one caveat of descriptive statistics for spatial data is that the measures don't always make sense. So spatial data is obviously far more complex than non-spatial data. And in that way, these measures that we just discussed aren't always going to make sense. because you're talking about spatial data, you're talking about the built environment or the physical natural environment. And some of these measures won't make sense in the context of the place you're actually looking at. So for example, if we took the mean center of the Golden Horseshoe, so the area around Lake Ontario, including Toronto, Hamilton, St. Catharines, etc. If you took the mean center of its population, you would probably find the mean center is in the middle of Lake Ontario. And if you're just taking it at face value, you would say, well, most people are living in Lake Ontario. Obviously, that's not true, as people can't live in the water, not realistically. So you have to take the information you're gathering from the descriptive statistics and take it with the context of your study area. So you can say, well, the people are spread evenly throughout the Golden Horseshoe, or there are a lot of people in Toronto, but there's also a lot of people in Hamilton, and that is creating a mean center located in the water. And there are other examples of this that I won't be discussing here. However, you have to understand the context, because in geography, that's always important. Context is always a very important component of your data set. Okay, so on to the R tutorial. The very first thing I want to show you guys is how to change the theme of RStudio. From the first tutorial, I was just using the default theme just so I wouldn't confuse you guys, because the color coding of different things is different depending on the theme you choose. So if you want to change that, you can come to Tools at the top, go down to Global Options, and then there's Appearance, and this might be set to Classic, so just go ahead, set it to Modern. And then down here is where all of the different themes are. So the default one is TextMate. That's what I was using in the first tutorial. You can see comments, so hashtag and then whatever you want to comment is green. And the functions are typically blue, and everything is black on a white background. I think this is horrible to look at, especially for a long period of time. So I prefer, and what I'll be using personally throughout the rest of the tutorials, is called Vibrant Ink. It's just a black background. The comments, so hashtag your comment, is purple. Functions are orange. Variables, or text rather, is green. And then everything else is white or gray. And I think this is probably way easier to look at for a long period of time. So that's what I'm going to use. I'm just going to hit cancel. But if you want to set your theme, hit apply. So I'm going to hit cancel. To load a project, we are going to go up to here into the top right, and it'll say project none. So click the down arrow here, and then open project. And my folder is on the desktop because it's easy. Going to go to week 2, our examples, not the answer key. And I'm going to click on W2 descriptive statistics.rproj, which is our project file. I'm going to open that. And basically what you'll see is down in the right corner, it opens the folder where the project file is. So the project file is essentially just telling R, hey, look, all of your data and everything you need is in this folder. And anything that is going to be output will be also in this folder. So it's just a good way to interact with your data And also, if you ever need to send your data to someone or send a R file to someone, if you zip up the folder and send it to them, it'll run exactly how it runs on your machine. If you don't use a project file and you send data to someone with an R script, they're going to have to manually change lines of code to point R to their data where their data is located on their machine. So this uses relative coding. So basically, you don't have to hard code and tell R, look, go to the C drive, go to Kevin's folder, and then the data's in here. It'll just know automatically where the data is. So that's why we're using project files. So once your project file is loaded, down here we want to select, in this case, descriptive statistics spatial.rmd. If you click that, it'll open up the R file and we can scroll up to the top. So just like with the first tutorial or the first assignment, if you've never used these packages before, you can hit Control-Shift-C, or if you're on a Mac, whatever the equal is to that, or you can come up to Code and then Comment, Uncomment Lines. And then once you do that, you can hit Control-Enter, or you can hit the play button here. I'm not going to do it because I already have these installed. And it'll just go onto the internet, look for these packages, download the zip file onto your machine, and it'll install the package. I already have these installed, as I said, so I'm going to just do Control-Shift-C, and that will recomment it. So now if you go to run this, it won't run it because they're just comments. You can see down here, just comments, just printed them to the console. What you do need to do is hit the play button to run these libraries. So you're telling R, hey, look, for this R script, we want to be using these packages, and this is where you're going to find the functions that we're using. These are the packages. So we always load our libraries. We're just going to import data now. So we have the data set that we're going to be using mostly in this is a data set of Airbnbs in the United States. This is mostly a data set of active Airbnbs that were at least listed in 2020. So 2021, obviously, not every Airbnb is going to be actively listed still. However, many of them are. And it's cool because they have URLs to the actual listings, so we can actually look at them. And this is a CSV file, so comma separated file. And the read_CSV function is used to read a CSV file, as you imagine. And you can see down in the right side, the bottom right, there is the file ab_us_2020.csv. This is how we read it into the program. And yes, you can import data manually. And yes, you can look into a data set and manually retrieve answers. But what I'm teaching you and what you're required to do for the assignments is always use code to do everything automatically for you. It's not acceptable to go into the data frame to look at the max value to retrieve it that way. That's not the point of these exercises. I'm trying to teach you how to use R. So I'm going to go ahead and hit the play button to read these into the program. This is the CSV file. This is a GeoJSON file. JSON is just, it's very similar to a CSV file. It's just using a different format. And then the geo part of it says, obviously, that it's a geographic file. So there's coordinates, etc., and geometry associated with the rows in the data set. And we're using the simple features. So this library is the simple features library, and it's a package designed to handle geographic information within the RStudio or R environment. And there is a function called st_read, which lets you read in geographic data. So we're going to call this one Boston because it is a boundary of Boston. And Airbnb, this is all of the Airbnbs within the United States. Well, not all of them. It's only, I think, 5 or 6 cities. And it's from 2020. So moving on, we're just going to clean the Airbnb data set. So the first thing we want to do is remove. So the exclamation point means not, essentially, N-O-T, not. We're going to filter where the availability 365 does not equal 0. So this is a not. This is the statement. So if the Airbnb basically isn't available, we want to filter out those rows. So that's how to do that. So this is basically going to output a true or false. If the row doesn't have availability, so if availability is equal to 0, this part of the function will output true. And we want to filter it out, so we're going to put the exclamation mark there. And I'll say, don't keep the true rows. And then we're going to use this pipe function, the percent chevron percent, to pipe that data that we've filtered into this next filter function. And we're going to do the same thing where we want to filter out the next statement. So there's 2 statements here. is.na latitude and is.na longitude. This function is.na is looking in your rows and columns, and it's looking for cells or data values that are NA, so not applicable, not available, whatever you want to call it. And we're just looking for if the latitude is an NA, or using this, the longitude is NA, then we want to filter those out of the data. So we want to remove them. So if we look up here in the top right, the Airbnb data frame, we open it with clicking this little chart icon, we can bring up the data set. So we're looking in these 2 rows, the latitude and longitude. If for any reason there is an NA data value, so if we're looking at the neighborhood right beside it, because it's conveniently there, this is an NA value. So if there was an NA in latitude or longitude, it wouldn't plot the point. So we don't want those Airbnbs because we want to be able to plot all of the Airbnb points in space. So that is how you do that. And that was also kind of what I was talking about before, about manually. Yes, you could look at a value to get a max value. You could click these arrows to look at the min and max values and get a data value that way. But that's not the point of this course. We are trying to learn how to code in R. We want to learn how to extract data using code. So let's go ahead and run this. And let's say for some reason you didn't want to filter this data out. You're like, well, now I have all of this data, so I have to rerun everything. Yeah, you could just overwrite the data, but for some reason you want to clear out this data from here. So the environment, the global environment, you can come up here and click this sweeping icon, the broom icon. And if you do that, it'll come up and say, do you actually want to clear all the objects out of the environment? And you click yes. You can see the environment is now empty. So it's just erased everything. This is especially useful if you're working on a project and you've created data frames that you no longer need. So if you're just testing something, maybe you want to create a test data set, and you're like, well, I don't actually need the test data set anymore, and it's cluttering up my environment. You can go ahead and clear it and then rerun your code, and you can get rid of that stuff. So now, instead of clicking a play button on 3 different chunks of code, what we can do is click this button. This button will run all chunks above. So it'll run this chunk of code. So it'll load the libraries, and then it'll write or import the data. So we can click that, and it's loaded the libraries in, and then it imported the data, and now we can just click the play button to clean the data set. So it's gone ahead and run that chunk of code as well. Now, the first thing we want to do is simply explore the number of Airbnbs per city. So the best way to do this is by using a series of functions in the dplyr universe. And the first thing we'll do, we'll create a new data frame called city_n. N is the number of, and we'll use this symbol to basically tell R to create a new data frame that's going to be called this. So we'll input the Airbnb data frame that contains every Airbnb. We'll pipe it into the group by function. So group by just says to R, look at this data frame and look into this variable specifically, so the city variable, and take all the rows and kind of just group them into those into that variable or that data value. And then in the next functions, we want you to base those functions on the fact that you've grouped by, in this case, a city. So the next function we're going to pipe into is called summarize, and this is used to, as the function entails, summarize the data in different ways. So you could take the mean, or in this case we want to take a count or total the number of cities or the number of Airbnbs per city. So n, the function n bracket is taking the number of rows by the group city. And then I want to arrange the data or sort the data in a descending pattern based on the number of Airbnbs per city. So let's go ahead and run this code. And you can see, if we open city_n, you can see that there's far more cities than I originally thought. I wrote this code a while ago. You can see there are 28 different cities. New York City has 25,648 Airbnbs in the city. And you can see at the very bottom, Pacific Grove has 140 Airbnbs. And as I was saying before, you can click this and it'll sort either descending or ascending based on however many times you click it, essentially. And you can do this if you just want to quickly understand your data. But for the purpose of the course, you cannot extract manually the answer and get a grade. You can also do it with categorical data, or rather alphabetic data. So words, and it'll sort by alphabetic. And you can see in the Airbnb data set that has all of the information, the city is here in the last column. You can see all of these Airbnbs are from Asheville, and the city _ N data set is taking all of those rows that are associated with or within the Asheville city, and it's just counting them up. And it's then outputting the number of Airbnbs or the number of rows that are in Asheville. So that's what this block of code is doing. So the next thing we want to do is create a data frame that we can then use to create maps with. So this is just an example of kind of a data set that we can use. We want to use the city Boston as our study area. So we're going to create a new data frame called Airbnb _ Boston. And it's equal to the series of functions that are here. So the first is just the data frame that we're going to input into all of the filter function and the mutate function. So taking Airbnb, piping it into the filter function. We want 3 different things in this data set. First, we want Airbnbs that are within Boston, the city of Boston. We want the room type to be the entire home / apartment. And we want minimum nights to be less than or equal to 6. And those are our characteristics or our filters. If we're actually looking on the Airbnb website, you can look for these filters. So with that in mind, we want all 3 of these things to be true. So we want the city equals Boston to output as true, aka only selecting rows where the city is Boston. We also want this one to be true. We're only looking at entire homes that are available. We're not looking for shared rooms or something like that. We also want only Airbnbs where it is less than or equal to 6 for the minimum nights, because we don't want to stay in an Airbnb that requires you to rent it for at least a week. We want all of these things to be true all at once. So we want every Airbnb to be in Boston, have the entire home, and also you don't have to rent the Airbnb for more than 6 days at a time. So we use this and symbol to tell R that we want all 3 of these things true for every single row you select. Now, if you used the OR symbol, so this line, if you use that instead of the AND symbols, it would tell R to select rows where the city is Boston and these 2 things aren't true. So the room type, it could be the city is Boston, but the room type is a shared room and the minimum nights is 30. It would select that row. Or it would be the city is not Boston, it's Asheville, but the room type is entire home apartment, and the minimum nights could also be 30 again. So we want to use the AND symbol to make sure that all 3 of these arguments are true, all at the same time. So after we've filtered the data, then we want to create a new column using the mutate function. Mutate allows you to create new variables. within the data. So we're going to create a new variable called total underscore cost, and set it equal to the price of the Airbnb per night multiplied by the minimum nights that you're staying. So this will differentiate and tell you how much you're actually required to pay to rent that Airbnb, because not all Airbnbs are available to be purchased for one night only. So we need a way to differentiate those Airbnbs from Airbnbs that can only be purchased with a 3-night minimum versus ones that are available for a 1-night minimum. So if we're actually looking for an Airbnb, that would be very important. So we will highlight this, Control Enter, and that'll only run the code that is selected. Then I thought, well, Airbnb underscore Boston would be kind of annoying to write every single time we want to use that data frame. So then I thought, well, okay, let's rename it to AB, so Airbnb Boston. And that's how we do that. So AB, then this symbol, the arrow symbol, and then the data frame we just created. This then creates a data frame called AB that is set equal to Airbnb underscore Boston. So you can see here in the top right, AB is our new data frame, has 809 observations, so rows, and 18 variables. And then you can see the one we created just before that with the different functions. And it has the exact same number of observations and variables because it's the exact same data frame. It's just easier to use AB, which is 2 characters, rather than Airbnb Boston. So we're just simplifying our lives. The next thing we need to do is import all of our spatial data. So we did already import the spatial data from the beginning. However, we need to do a couple things before we can actually use it. So the first thing is we're going to give the data set a coordinate system. So most data is probably going to be in WGS84, which is a geodetic system. And the way we can assign that data or that coordinate data to the data frame is by using set underscore as underscore SF. You put in your data frame, which is AB, comma, and then the coordinates you have to tell are which variables or columns are the longitude and latitude. So coordinates are the longitude column and the latitude column. That is the coordinates. And then at the end is CRS equals 4326. CRS is a means of setting an ID number to a coordinate system so that different programs can identify a coordinate system based on a number. So the WGS84 coordinate system is identified using a CRS value of 4326. And then once we do that, we can click on that line of code, hit Control Enter to run that code. That creates a new data frame called ABS. It's not actually a data frame technically. It's actually a simple features file or a spatial polygon. The next thing we want to do is set a projection for the data frame. So we use st underscore transform. This function takes the geodetic coordinate shapefile and converts it to a projected data frame or shapefile, however you want to think of it. You input the data frame. So this is the data frame, ABS, inputting that. And then CRS again equal to 32619, which is associated with the UTM zone 19N, which is the UTM zone for Boston. If you recall from another course, the projection for Toronto or Hamilton is UTM zone 17N. So Boston is just a little bit east of where we are, and thus it's UTM zone 19N. So we will run that code as well. And the next thing we want to do, this is kind of basically when you run that, it changes the way the data frame is treating different variables, especially the coordinate system. So if we look at the ABS data frame and scroll to the right, you can see there isn't a latitude and longitude variable anymore. There's no column for latitude and longitude. But what it did do is create a new column called geometry, which has the latitude and longitude, but it took the degrees units and it converted the latitude and longitude into meters, because that's what UTM zone projections use. So this isn't as useful for us anymore. And we also need, in addition to the geometry, we in addition need a latitude and longitude so we can calculate things like mean center. So the next thing we'll do is create a new column called chords, so coordinates. We do that by doing the data frame $, and then column, and this is a new column. Set it equal to as.character ABS data frame, and then the geometry column. Let's run that line of code, and then let's look in the ABS data frame again to see what happened. So basically, we took the geometry column and we created a coordinate column that has the exact same data. It's just that instead of being geometric data that can be read by a spatial function, the coordinate variable is just a text version of that kind of mathematic geometry that is in the geometry column. So next thing we need to do is kind of clean that data up. So we want to extract just the latitude and just the longitude values and put them in separate columns. We have to take away the C, we have to take away the bracket, the column, and the other bracket. The way we can do this is through a little bit of functions. You don't really need to know how to do this, but I will show you kind of what's going on. So this line of code removes the C bracket and the other bracket from the coordinate column. So it's going to take away the C bracket and then the other bracket at the other end. So if we run that, it uses the substring function, takes the column, and then the 3 is associated with the substring function, tells you where to stop, eliminating the text or characters. And then this is saying at the end of each text, we want to remove just the last character. So if we look at what happened, you can see it took the first 2 characters and it eliminated it, so C in the bracket, and then it took the very last character, which was the bracket. And we had to do that in a kind of special way like that because not all of the coordinates are the same number of characters. So you can see in this row here, this value, the latitude, is only 4 decimal places, whereas other ones have, something like 8 decimal places. So you kind of had to use this kind of special way of selecting the last character. So the next thing we want to do is separate the first number from the second number. We can do this using the mutate function in dplyr, and we'll set longitude underscore m because it's in meters, and we use sort of a nested function. So we want the value in the end to be numeric, and we're going to use the string split fixed function from dplyr, and it's basically looking in this variable or this column, and it's looking for a comma and a space. So it's looking for this right here where it's a comma and then a space. So in between the two numbers, it's looking for that sort of pattern. And this too means that it's taking that location in the cell, and it's separating the data into one column and then a second column. And then this at the end is saying to select only the first column, because it's outputting 2 columns of data and you want to select the first column. So if we run this, and then just to be clear, I guess, in the second column that we create, latitude underscore m, we're again setting it to a numeric value. So we want this data is going to be output as a numeric or a number. It's taking the text and it's converting it to a number. And this will take this same data, but it'll just take the second column that it creates. So if we run that, we look again at the data frame, what happened. You can now see we've created a longitude underscore m and a latitude underscore m. And we found, based on the comma and the space, which is the same in every single row of the coordinate variable or column, it looked for that pattern and it took to the left of that pattern and then to the right of that pattern and put them in 2 separate columns. And that's how that happened. And now those are also numeric values. So you can see that they're numeric. You could use code to figure this out, but you can also see because text and characters are always left justified. So you can see because this column is bigger than the data now, you can see that this text is to the left of the column. It's justified to the left, same as like a Microsoft Word or something. Whereas the longitude underscore m is right justified, so it's toward the right of the column, and that's how you can easily delineate the difference between text or characters and numeric numbers. And you can see here the header between geometry and coordinate is now no longer actually in the middle of the data. And this is just a bug of our, your data is not messed up. It's just happens sometimes. So just keep that in mind. And then the next thing we're doing is we want to take this data frame and we want to take the ID and the longitude and latitude and join it to the ABS data frame that we just created. So the ABS data frame is the Airbnbs in Boston, and it's Dispersion one. That's what the S means. And we want to join the ABS data. That's the data frame we want to use because it's spatial. But we want to take from the non-spatial data set, the AB data set. That's our other data set. And we want to join the ID, the longitude, and the latitude to the spatial data set. And the reason we want to do that is because the longitude and latitude from the non-spatial data set is in degrees, and our spatial data set, longitude and latitude, is in the UTM projected units. So we want both, basically. And we use the left underscore join function to take the spatial data frame, and then we're joining the non-spatial ID, longitude, and latitude columns by the ID. So it's looking at the ID number of each Airbnb, and because the ID of the Airbnbs never changes and it's always the same, we can join the rows from the spatial data set and the non-spatial data set, and we can join them, and R knows, okay, this row goes with this row because the ID number of the Airbnb is the same. So that's how you do that. Let's run this code. Now you can see in the ABS data frame, we scroll to the right, you can see we have longitude and latitude within the meters unit system. And then we also have longitude, latitude in degrees, which is important for things we want to do. Next thing we want to do is we need the data to be in a specific kind of a way in order to do certain things to it spatially. So the first thing we need to do is create a distance matrix in order to do the median center. So this is what I meant about it being kind of complicated to do location allocation or median center within R. If you're using something like ArcGIS in ArcMap, this is a very trivial task because the Esri people on the back end already coded all of this stuff. So when you use location allocation in ArcGIS, it's super easy and intuitive to do. But when you're actually having to do it manually and code everything manually, it's much more difficult. So this is just kind of to show you how it works. I'm not going to go through all this code because it's kind of outside the bounds of what you need to know. This is kind of more complicated. So I'm just going to go ahead and run that. And we're just going to move ahead. We don't need to know that. Standard distance. So we talked about this in the lecture, and I showed you how to, well, I showed you the calculation, and we're just going to go ahead and go through the calculation here, not line by line necessarily, because you can just see how it matches with the calculation. I don't want to bore you, but we can find the mean of X by using the mean function. ABS, that's our spatial Airbnbs in Boston. That's the data frame, and we're going to select the column that we want to look at using the $sign. So we're going to look at the longitude, which is our X coordinates. Longitude lines go up and down, and it's kind of counterintuitive that they're on the X axis, because since they're going up and down, you can count left and right how far they are. So that's why it's an X axis. And latitude lines go east to west, and they're kind of stacked like rungs of a ladder. And that's why you can count them up and down, and that's why they're Y axis. It's something I always mix up because it's so counterintuitive. But longitude is X, latitude is Y. So yeah, we just took the mean of X, so MY or MX and MY is the mean of the X and Y coordinates. Then for the numerator, so the top part of the calculation is the sum of the longitude minus the mean of X squared, and then you're taking the sum of those squares. And then very similarly on the bottom, but just for the Y coordinates. And then the standard distance calculation is the X numerator plus the Y numerator divided by the number of Airbnbs in the data set, and you're taking the square root of that value. So when you run all of this code, it will output, I just selected a little bit too much there. So I'm going to run this, and it outputs at the bottom here 3,540.981. Also note down here, it also outputs the answer to the console, whereas this is outputting it to the R markdown file. So what if we wanted to find the standard distance of a bunch of different point data sets? You're probably not going to want to calculate this manually for 10 different data sets. So what can we do to eliminate that repetitiveness? The brilliance of coding and learning how to program is by taking repetitive tasks and making them easy to run multiple times with different data, different variables, different values, etc. So we can simply take these calculations, these lines of code, and we can create a function in R that we can then use to do this calculation multiple times with different data frames, different variables, different values, etc. So we simply essentially take this data and copy it, paste it into a function. So this is, instead of a data frame, we're creating a function. So this right here that's highlighted, standard underscore distance or std underscore distance, this is what our function is going to be called. So we're going to set it equal to, with the arrow, function, and then brackets, and we're going to call this spatial underscore data. So the output, I'm going to go over this in a second, but I think it's more intuitive if I show you what the outcome is. So in the end, we'll have a function called standard underscore distance, and it takes a spatial data frame. So in our case, the spatial data frame is called ABS. It's Airbnbs in Boston, and it's the spatial version with the geometry. So that's the outcome of this function. This is the lines of code that create that function. So this is the name, as we see. This is the function called function that we use to create the function. Very confusing, I know, I'm sorry. This is what the function will take, the argument. This is the argument of the function you're creating. You can name this anything you want, but in my advice would be to name this something intuitive, in this case spatial underscore data, because you want to input your data. This is then important because all of your lines of code have to reference this input. So in this case, we took these lines of code and we copied and pasted it into here. So you can see these two lines of code correspond to these two lines of code. The major difference between these two lines of code is up here, we have ABS and then the $, longitude underscore M, and ABS $ latitude underscore M. Whereas here, we have spatial underscore data $, longitude underscore M, and spatial underscore data $, latitude underscore M. So this spatial data is referencing the spatial underscore data that we have as an argument for our function. So again, if we look down here at the finished product, standard underscore distance is the name of the function that we created using this. And then in brackets, we have ABS, which is the Airbnbs in Boston, and it's the spatial version. And this is our input into our function that we created. So this here is a placeholder for a data frame that you're inputting into this function. So then you can see that since it says spatial underscore data here, this spatial underscore data is what it's using to do these lines of code, to complete these lines of code. So if we're inputting the ABS data frame into our function, it's going to read this as mean of ABS $ longitude underscore M. And then the same for here, the X numerator and Y numerator. The only difference is that in the manual version, we're inputting the ABS data frame directly into the code, whereas this is using the function input or argument as the placeholder data frame. So again, in your finished product, standard distance, and you input ABS data frame that we have created, this X and Y numerator are going to be using ABS in place of the spatial underscore data. And then lastly here as well, you are inputting ABS in place of spatial underscore data. The last thing, and the only other thing that's added to the function is this last line, which is return. It's the return function, and it's only used within a function, and it basically just says to our, okay, when you're done running this function, you have to actually return the value in the end. And this could also be a print function, but here we used a return function, and it basically just tells our, okay, when you're done all of this, take this standard distance and output it into the console. So if we run this function to create the function, it'll run and it'll be like, well, nothing happened. Why didn't it work? It was just creating the function. So this is your own custom function. And you can see here in the top right in the environment, there's now a grouping called functions, and the function's name is standard underscore distance, and the function takes a spatial underscore data argument. Now what we can do is actually run this new function that we created. So standard underscore distance, our input, so the spatial data that we're inputting is the ABS data frame. So let's run this code. You can see it ran all of that code and it output the exact same value as the manual version. So let's do this again. We'll run the manual version again, 3540.981. Now we run the function we created, exact same value. So this is really creating functions in R or other programming languages is sort of like the point of using coding or a programming language. It's a means to take tedious, repetitive tasks and output something very easily. And as I'll show you in the tutorials to come, you can take these functions that you're creating and output a lot of data all at once with very little intervention. So to move on, we want to compare, taking this standard distance function, we want to compare different kind of subsets of the data. So let's look at the Airbnbs, the top 10 that cost the most. So we'll create ABS underscore top 10. And then we'll also look at the bottom or lowest cost Airbnbs. Also the bottom 10. So the only difference between these two lines of code is that we are sorting the data descending for total cost. So that's top 10 if they're top down. So max is the max total cost is the highest value, and then descending from there. And then in this arrange function, we don't specify descending, so it defaults to ascending. So the top value in the data frame is the lowest cost Airbnb, and we're taking the top 10 rows of the data set. So now what we can do is create 3 lines of code where we're going to output the standard distance of all Airbnbs from the spatial data set. We're also going to round this value to 3 decimal places. We are also going to create a sentence based on the output. So we're going to use the paste function. The paste function allows you to print character or text in addition to numeric values, and it outputs it all as one kind of sentence, essentially. So if we print this, you can see 3540.981 meters, and it says all 809 colon all 809 Airbnbs in the US, and the standard distance is 3540.891. But if we run all 3 codes, or all 3 lines of code at the same time, you can see, so all of them, the standard distance is 3500. Just the most expensive ones, the most expensive top 10, the standard distance is higher. So that tells us the most expensive Airbnbs are more spread out than the entire data set. And the cheapest 10 Airbnbs are also more spread out than all Airbnbs. So to move on, let's now do the weighted standard distance. And instead of even going through the sort of manual code, we're just going to go straight into creating a function. So the main difference is between standard and weighted standard distance is that with the weighted standard distance, we're taking a variable within the data set and we're using that to weight the distance. So in this case, our weight is the total cost of the Airbnb. So the difference between this function and the last one is that in addition to the spatial underscore data argument, we're going to add a second argument called weight. So this code here is going to be referencing both a spatial data frame in addition to a variable or column in the data set called weight. So this is all of the code. Not going to go through it because it's basically the same as the last one. The only difference is that we're adding a weight to the calculation. And again, we're going to return the last value. And if we run all of this code all at once, so select it and then Control Enter. Oh, we didn't run the function, and it's saying, what is this function? It says error in this function, could not find the function weighted standard distance. It's because I didn't actually create the function. So I need to select it, Control Enter. Now it's created the function here, you can see. And we'll go ahead, highlight this, Control Enter. Now you can see the weighted standard distance for all Airbnbs is 9,182. In this case, we rounded the value to 0 decimal places. The most expensive 10 Airbnbs has a weighted standard distance of 6,000, so it's more concentrated. And the cheapest ones are 113 because the total cost of them is so much lower that the value that you get in the end is very low because they cost very little. Okay, next thing we will look at is relative distance. So this is where we're taking the standard distance and dividing it by the area. So the first thing we need to do is create a value of the area of our study area. So in this case, Boston, we want to calculate the area of Boston. So we're going to create a new variable called Boston_area. So essentially we're going to take this output, so the value that is output from here, which is the area of Boston, and we're taking that number value, and we're just saying, okay, that number value, we want to be able to call it in other functions or other equations, but instead of using the actual value, we want to call it Boston_area. So st area is a simple features function that, as you guessed it, it's just going to calculate the area of Boston, and we divide that value by 1,000,000 to, instead of having the area in meters squared, we want it in kilometers squared. So we'll create that, and you can see here Boston_area is associated with this area value. Now what we can do is, same as the other examples, is create a sentence that has what it is and a rounded version to 2 decimal places of the standard distance function of ABS data frame divided by the Boston_area number, so the area of Boston. And if we run all of this code at once, you can see it's outputted all Airbnbs in Boston. The relative distance is 28.3. The most expensive Airbnbs in Boston, the relative distance is 35.32. So they're more spread out. Or they take up the bounding box of the Airbnbs takes up more space than all of the Airbnbs. And lastly, the cheapest 10 is 31.34, so they are also fairly spread out. Okay, now we will move on to taking this spatial data and actually mapping it into what's known as a leaflet map. So leaflet is basically an open source freely available method of using, again, free maps to output spatial data onto an actual map. And the cool thing about leaflet mapping is that you can also make these maps interactive. So the first thing we need to do is create icons. So the little markers on the map that are used to show where, in this case, Airbnbs are located. So the first one we'll make is called custom point. This is the variable, the name of the variable, or the name of the icon or marker. And this will be for all of the Airbnbs. So we use a function called make icon, and R is case sensitive, so it's important that you take note that the I is a capital and the other letters are lowercase. The first argument of this make icon function is called icon URL, and it's set equal to a URL. So if you go to this URL, you can see the actual icon that I'm using. And I'll show you how to actually do this. So I'm gonna just open a web browser. Let's look up, let's look up the icon that I have set there. So hit enter on that. You can see it's just a white dot. And the way you can get an image to use is by putting in, let's say, white dot PNG, and hit enter on that. Go to images, and you can select one, click on it, and then right click on it and go to copy image link, and then you can paste it down, and it'll use this image that we just found as a image for the map. And it's important to put a PNG file because it'll take the background and set it as transparent. So you'll have, in this case, an actual circle versus a square with a circle in it. That'll be more clear if you can just kind of experiment, see what happens. The icon width in this case is 5 pixels by 5 pixels. This is something you should kind of experiment with for your own maps because it depends on the size of your map and the extent that you're looking at, etc. The icon anchor X and Y, this relates to where the middle, quote unquote, of the icon is. So in this case, it's right in the middle. So 5 divided by 2 is 2.5. So in this case, the anchor, or where, in this case, the Airbnb will be centered directly on the icon. So if we run this, we will create what is known as custom point, which you can see here. We click on that, you can see the information related to it, and you can see it's a leaflet icon. And then we are just going to do that for all of these other icons that we're creating. So the most expensive Airbnb, that is going to be called expensive underscore points. This relates to, let's see, I forget what the icon was. It's a green dot. Cheapest, cool, money icon. So this one, I just want to show you because I just want to show you because you're using pictures that are just off the internet, you can literally use any picture that you want. In this case, I believe it is an emoji. Yeah, so I found the emoji for the money, the guy smiling with the money, as you can see. And that's the icon that I'm going to actually use on the map. So that's fun. Mean center. I'm actually just going to highlight the last two and run them at the same time. So weighted mean center and then median center as well. And I encourage you guys on the assignment, when you're trying to find pictures to use for the points, that you find just anything you think is fun or funny or whatever. Make sure it's appropriate, obviously, but and also make sure it's not only appropriate for school academically. You can use emojis or a funny picture, but also make sure it's sort of descriptive of the point that you're using. So instead of a white dot for Airbnbs, you could use a picture of a house or something if you wanted. You can also use pictures of a person's face or something, but again, make sure it's appropriate. Okay, this is actually this next chunk of code is actually how to create the map itself. So the function we're using is called leaflet. The only thing you need to put in this is the data that you're using. So data is equal to ABS. So that's our spatial data set of the Airbnbs in Boston. We're going to use the pipe function, I guess you can say. And then we will put in all of these different markers and the set view and the provider tile. So as you can see, I have formatted this so it's easier to read, but you could just have it all on kind of one line. But because it's a little confusing to look at this line of code and read everything, so it's easier if you add a line after each argument of your function. So this is the first argument, this is the second argument, and this is the third argument. So I encourage you to write your code like this because it's just easier for you to look at. And if you do part of the assignment and then come back to it later, a few days later, it might be confusing for you to look at again. So I encourage you to write your code like this. You can also have comments in between lines of code, and because they're commented out with the hashtag, R will just read the comment as a comment and go to the next line of code. So in this way, it's also very easy to read and understand what each block of code is actually doing. So once you read in the data, you can pipe it into what's known as add provider tiles. Again, it's case sensitive. And we can use providers, $, and then this is a very specific base map. And it says here in the code, check this website for more base maps. So if we go here, go to the website. This is a website that is dedicated to showing you different types of base maps that you can use. Very important note about this is not all of these base maps are freely available. Some of them require a API token, and I kind of wanted to show you how to do that, but then again, it's very confusing if you're new to it, so I decided not to. And also, when you're creating your maps, if you understand how to create an API token and how to use it, do not use it for the assignment because the people grading your assignments aren't going to have that API token. So do not use anything that requires an API token. So you can look through these and just click on them and it'll show you what your map will look like when you're using it. And again, I encourage you to explore these different base maps and use whatever base map you want, but just make sure that it does not require an API token and that it will display the base map. So all of these will require providers, $, and then whatever it's called. So you can see here, here's the one that I was using. It's called cardodb.darkmatter. So providers, $, and then that. But if you wanted to use, say, this one, I don't know if this one's freely available, so keep that in mind. You would just put providers, $, MTB map, or providers, $, stamen.watercolor. I'm not grading you on how nice your map looks, so you can explore and experiment, use whatever icons or base map you want. Just make sure it's clear that the icons are easy to see and click on, and that the map is functioning, essentially. So that's how you do that. And you'll pipe this into the next function, which is called setView. And basically, the setView is the first, the distance from the surface of the Earth, and also the location and space that it'll show you first. So after you've loaded the map, you can zoom in and pan around to look around, but this is going to be the first kind of viewpoint that you see the map. So what I've done is, for the longitude, I took the mean of all longitude coordinates, and then the latitude is the mean of all latitude coordinates. So it's centering the map. The zoom level is something you'll have to experiment with depending on your data. Zoom equals 11 isn't always going to work. It might be too zoomed in, or it might be too zoomed out. Try to pick a zoom level that frames the data, or at least most of the data. It doesn't have to frame all of the data, but at least most of it. And then you want to pipe that again into this next function called add markers. So this is going to be, you're going to have multiple add markers functions to create a set of points or a set of markers for every different thing you want to show on the map. So this first one is the custom point icon, and you'll put in longitude equals ABS $longitude, comma, latitude equals APS $latitude. The icon is the custom point marker that you created up here. And then you'll have another thing, potentially, not always, but if you want to have a pop-up, or for the assignment, it says to have certain information in your pop-up. You'll have pop-up equals, there's supposed to be you don't need spaces in between stuff, but I think having a space in between stuff makes it easier to read. So there's supposed to be a space there, but it doesn't matter. You'll have paste, and it'll come up with total cost with a $sign as a text, an actual $sign. And then you'll have it output the ABS top 10 $sign total cost. So when I print this and you see the map, it'll all make sense. And then you have cheapest Airbnbs. We'll have we'll have all Airbnbs. We'll have most expensive Airbnbs, cheapest Airbnbs, mean center, weighted mean center, median center, and we'll have Airbnbs with the maximum total cost. And if we run all of this code, you can see down here, we have a map of Boston with all of the Airbnbs and then all of the other markers that I placed down. So we zoom in here, zoom in down in this area. If we click on this, sometimes it can be a little hard to click on them because they're so small. You can see it comes up with a pop-up that says this Airbnb right here that you clicked on, this one costs $596. You can click on this one. So this is one of the cheapest 10 Airbnbs, $79. This is one of the most expensive Airbnbs, which is over $3,500. We have our mean center. So all it does is it just says this is the mean center. We have the weighted mean center. I used a scale to indicate the weighted mean center. Then we have our median center, and down here we have our most expensive Airbnb, which is well over $5,000. And, you know, this cheap one is $75. So you can kind of zoom in and out, pan around. You can click on the different markers. The markers will come up with information pertinent to that point. And I think it's a great way to visualize data. You can do it all through R, which is really cool. And you can create maps that are honestly in some ways better than a map that you would create in ArcGIS. And it's very intuitive and very easy once you kind of get the initial hang of it. And you can see, just to kind of visualize the lecture information, is the median center. This is a point in space that minimizes the distance between this point in space and all other Airbnbs in the data set. This is the mean center, so this is just the mean of all x coordinates and all y coordinates. And so it's basically in the middle, as you can see. Well, I mean, it is in the middle, but you can see that it's in the middle visually. And then the weighted mean center, because it's the mean center, but it's being weighted by the total cost, you can then see and you can understand that it's toward the southeast. And I'm sure you can understand that because the most expensive Airbnb is down in the southeast of Boston. So it's taking that information of where the most expensive Airbnbs are, and it's pulling the mean center toward those more expensive Airbnbs. And although there are the majority of the top 10 most expensive Airbnbs are in this north area, there are 2 other Airbnbs that are in that top 10 down here. And because they're sort of outliers from this other grouping, basically the 2 Airbnbs are making up for the 5 or 6 that are up here. And then laterally, so left to right, since the most expensive Airbnb is down here and to the right or to the east, it's pulling the mean center to the east. So that is why the weighted mean center is located there in relation to the mean center here. And it is my preference that the black or dark gray base map looks best to visualize data. That might not be true for you. That's what I think. But I encourage you to use different base maps, explore different ones, have fun with it. and have fun with the icons that you use as well. You don't have to use the conventions of map making. This isn't a cartography course. This is a stats course. Stats is already boring enough, so try to have fun with it. So this is an example of how to do almost everything that we talked about in the lectures. I hope the tutorial section kind of gave you a better understanding of the lecture content, and I hope my explanations of the code were good. I understand for many of you coming from computer science courses that these tutorials are probably very tedious for you, but for the people that are learning R for the very first time, or learning a programming language for the very first time, learning stats for the very first time, that my explanations are thorough and everyone can kind of understand what's going on. I encourage you, because these are YouTube videos, that if I'm being too tedious, just change the playback speed to faster so that you can go through it. Or if you understand coding and you don't need the explanations, you can just look at the RMD file and go through the chunks of code on your own to understand what's going on. But hope that helped, and see you next week.